Objective: to know about the discovery of cathode rays, their properties, and the discovery of electrons. The atomic theory, first put forth by John Dalton, could not explain the result of many experiments conducted by scientists between the 19th and the 20th centuries. For instance, it could not explain the electrical nature of matter explained by Michael Faraday through his experiment in 1830. Heinrich Geissler, a German inventor, developed the mercury pump and produced the first good vacuum tube. This tube, after being modified by Sir William Crookes, became the first of its kind to produce cathode rays, leading eventually to the discovery of the electron. William Crookes discovered cathode rays while studying the phenomenon of electrical discharge in gases, and J. Thomson discovered that cathode rays consist of negatively charged particles called electrons. Let us now take a closer look at the sequence of events that led to the discovery of electrons. Cathode rays were produced in a discharge tube. Hence, a discharge tube is generally referred to as the cathode ray tube. The cathode ray tube is a partially evacuated glass tube with the cathode and anode placed at the two ends of the tube. A vacuum pump is used to partially evacuate the tube, and the cathode is connected to a high voltage power source. It is supported on a stand. In this setup, Crookes observed that an electrical discharge through the gas took place only when the pressure within the tube was lowered to 0.001 mm of the mercury, and the potential difference between the electrodes was as high as 10,000 volts. This is when current starts flowing inside the tube. To study the behavior of this current, Crookes punctured the anode inside the cathode ray tube and coated the glass tube behind the anode with zinc sulfide before repeating the experiment. The result was a bright glow of fluorescence that was observed on the coating behind the anode. The bright fluorescence resulted due to the striking of the rays emitted by the cathode. These rays were therefore named as cathode rays. J. Thomson in 1897 studied the properties of these cathode rays through a series of experiments. He observed that when an opaque object is placed in the path of cathode rays, a sharp shadow was formed. This led to conclude that cathode rays travel in a straight line. In one of his experiments, a pinwheel was found to rotate when placed in the path of cathode rays. This helped him to conclude that cathode rays are made of particles that produced mechanical motion. He also observed that a metal foil, when placed in the path of cathode rays, becomes hot. He then concluded that as cathode rays generate heat, they must possess some kinetic energy. When cathode rays were allowed to pass through a metal foil, a glow was seen behind the metal. This indicated that cathode rays had the power to penetrate. However, when he applied the electric field perpendicular to the path of the cathode rays were found to deflect towards the positive plate of the electric field. He observed the same result when a magnetic field was applied. As opposite charges attract and the cathode rays were found to deflect towards the anode, he concluded that cathode rays consist of negatively charged particles. He called these negatively charged particles as electrons. When cathode rays were allowed to pass through different gases, glows of different colors were observed in the tube. These different colors were seen due to the ionization of gases. This confirmed that cathode rays could ionize the gases. Through a series of experiments, Thomson observed that the properties of cathode rays do not depend on the nature of electrodes or the nature of gases present in the cathode ray tube. This led him to conclude that electrons are the basic constituents of all matter. Summary: J. Thomson discovered that cathode rays consist of negatively charged particles called electrons. Cathode rays are produced at a pressure of 0.001 mm of mercury and a high voltage of 10,000 volts. Cathode rays travel in straight lines and consist of negatively charged particles called electrons. Cathode rays are affected by both electric and magnetic fields. Cathode rays have kinetic energy and cause heating effect. Cathode rays can ionize the gases and have the power to penetrate. Electrons are considered to be the universal constituents of all matter.